So for this afternoon, muna itong topic, Zener Diodes. So first off siguro, para ma-understand na to ang operation and characteristics of Zener Diode, let's compare it with our regular junction diode or regular rectifier diode. So ang iyang symbol is this one. Maragya po regular na junction diode but na siya diagonal lines here. So sungay-sungay kibali. And although the same ang gyapon, anode cathode gyapon ang terminals sa negative and positive respectively. But for us to forward bias it, for us to use it sa iyang full potential, we need to reverse bias it. So, ang operation sa Zener diode is in the reverse bias na operation. Reverse bias na state. Operates in the reverse bias na state. Reverse bias. Okay. So, magyapon ni ang anode and kanigapon ng cathode. But again, kinanglan na to i-reverse bias. No? So, notice, dili the same ang ilahang polarity. No? So, that would make our diode in the reverse bias. And in that case, nagamit nato iyang full na potential which is for voltage regulation. No? Voltage regulation. Or it will act as a voltage regulator. No? So when you say voltage regulator, it will create a fixed na potential. No? Fixed voltage. So remember before that approximately this is the characteristic curve of a diode. For any diode, no, even ang Zener diode mo, gyapon yan characteristic curve. So, kung naka-forward bias is like that, no? Which this value is VD, no? And for reverse bias is wala, diba? Ideally, wala current, nega-flow in the reverse bias region. And for some voltage, we call this one VZ. For some voltage VZ, pag ma-reach na po nga voltage, in the forward bias region, again, if ma-reach ang VD, mag-flow ang current. In the reverse bias region, if ma-reach ang VZ, na po yung current ka mag-flow. Like that. But if this is a regular diode, regular junction diode or rectifier diode, once ma-reach ang VZ and na current mag-flow, automatic, magguba si diode. Okay? Buto. Kadigid siya ng buto na masunog lang. Ayan na. If it is a regular diode. But if it is made as a Zener diode, dili siya diretso maguba. While in fact, mao gid ni ang full use of the Zener diode in this region. So naa dire. If we use the Zener diode as in the forward bias region, mala lang siya og regular nga silicon diode, no? So gamay lang nga side note, in forward bias region, Marlin siya silicon diode na iyang VD is equal to 0.7 volts. So, may palit na lang taog normal nga diode. So, example, ito mga circuits before, no? Like that, but Zener diode. So, pareha, no? The same lang ang solution, the same lang ang behavior and characteristics, so on and so forth. But, if we use it sa iyahang reverse bias na mode, like this one, no? Nagyapoy current nga mag-conduct sa circuit. So, in any case, whether naka-reverse bias ang Zener diode or naka-forward bias, current will conduct. Okay? I think walang idea here. Lahi lang ang values nila sa ilahang VD. No? So, let's say, for example, 5 volts ang atong source and ang atong VD is 4 volts. Ang VR would now be only equal to 1 volts or 1 volt. No? And mo po na ang naka-differ sa Zener diode and regular silicon diode or regular na rectifier diode. Ang iyahang VZ, this one, is relatively higher, no? Much higher compared to 0.7. No? Abot na siya from natay isa ka example here later. Kasi mga range of values sa VZ. Okay? Fixed no na siya. No? It's for each device, it only has one specific VZ, but nagkaya mo klaseng nga Zener diodes. No? I think we'll learn that later. So I hope this slide summarizes what I just said. Zener diode is a diode operated in the reverse bias at the Zener voltage, VZ. When the input voltage is greater than VZ, the Zener is on. No? So, this yung gyapon sa regular nga diode. No? Dapat, ang input voltage is greater than VZ for it to conduct in the reverse bias mode. Zener is on. But when VI is less than VZ, Zener is off, and Zener acts as an open circuit. Kung nakaingani siya nga, naka-reverse bias siya nga position, pero ang VI kay gamay, no? Gamay og value. So, I think mas better illustrate ni sa isa ka example, no? So, kung series ang kuan, no? Just to clear things up. Kung series ang atong circuit, just like this one, mag-conduct gyapon ang Zener diode but 0.7 volts lang. Kung naka-reverse bias, depende sa VZ. Pero lahat na po na siya nga story kung naka-parallel. And I think these conditions apply to when the Zener diode is in parallel. No? So, wala man day asterisk diri, no? So, kita na lang butag asterisk. This is only when Zener diode is in parallel. No? Because aya lang po nato siya magamit as regulator gid actually kung naka-parallel. Okay? Aya man magamit iyang voltage regulation nga capability if naka-parallel ang Zener diode. So far, any questions before ta mag-kanog example? Mas better ni ma-clarify na sa example pero yeah, kasi na mo yung questions. Okay, wala ka so far. Sige, patayin ta ha. So I have here an example of a specification. Ayan. Sa
Ay,
man kuan. Why?
good afternoon, sir. Kaning sir,
Afternoon.
pwede pa i-repeat sa first lang, sir, kay late mo ito naka-join.
Hmm. Ah, sige.
Sige, sir.
Di nung ko sure kung asa ka tama nakasulod, no? Pero anyway, naman po ni sa kuan, naka-record po ni, so uh, pwede na niyo mo i-refer dito later. Pero I think for kuan, sa beginning na to na mention earlier, ang Zener diode kay operating in the reverse bias na mode. Oh. And yung main nga purpose is for voltage regulation. Kana. Ay, asa pa man, why? Kay basig, di ko sure kung asa ka tama nakasulod.
Sige lang, sir. Sige lang, sir. Continue na lang, sir.
Sige, continue
Na-recorded
na
na
lang.
din. Thank you, sir.
Sige, sige. Okay. Uh, anyway, even if naka-miss out kanina, I'm sure mas mag-clarify na later sa mga examples pa mapod. Sige. I have here an example of a specification sheet of a Zener diode, no? So, muna iyahang part number 1N47 series, no? So, from 4728 to 4764. So, 1N47 series. So, yan yung itsura. No? I think I've shown this before sa lab. Yahang casing is glass. Glass yun ito, no? Transparent man siya compared sa very common na silicon diode nga black na plastic epoxy. So, glass yung case guy. Siguro for insulation purposes na siya. So, here are the maximum ratings. Junction temperature, source temperature. Iyahang maximum power dissipation is 1 watt, no? Ato dapat nintiman-an. Ang most important here is this one, no? 1 watt. Iyahang maximum power dissipation. And so many 1.2 volts iyahang forward voltage. Okay, dili siguro 0.7 iyahang forward voltage in this case, but 1.2. So dili 0.7 so given 1.2. Anyway, given man gid na siya always. So pa ba diling? I think morning, no? Morning general na character general na characteristics, no? Maximum ratings for all Zener diodes in this series. So this is a table of all the available Zener diodes, no? From 1N4728 up to 1N4764. So muna yung mga Zener diodes. Asa sila differ? Here, no? So nominal Zener voltage. This one. No? So it can go as low as 3.3 volts. Diba? Or as high as 100 volts. No? So nada ay 100 volt nga Zener diode. So yung symbol gamit na doon, VZ. VZ. So meaning, if natay voltage source, this is our source resistor, this is our load, we want to apply a constant voltage to the load. Remember na the higher or the lower the value of resistor RL, the higher or lower the value of the voltage drop across the load. No? So meaning, what if nag-degrade ang atong kuan or nagbaylo-baylo kibali atong load, no? Naglaylahi ang value, naglaylahi ang resistance. So ang effect maglaylahi po ang value sa load voltage. And what if we don't want that, no? Gusto ta fix lang yun. So, meaning whatever value sa load, atong i-apply here, RL, but we want a constant voltage source, voltage drop across the load, so we should apply a Zener diode in parallel with the load. And its voltage drop or the voltage nga iyang i-regulate would be equal to VZ. And it could be found in this specification sheet. So let's say, for example, 1N4735 ni siya nga Zener diode. 1N4735. No? So, given kibali na siya. So, mangita tag specification sheet. And its VZ nominal voltage is this one. 6.2. 6.2 volts. The other important parameter here, ang uban ani nga mga parameters kay na-measure ni siya katong gi-test, no? Gi-test ning device. But another important value here that for us to take note of is this one, no? Kung subayon ako sa 4735 kani, no? Most of the time, pwede lang na to i-ignore ng other values. Well, except again for the nominal Zener voltage and the maximum regulator current. This one. Meaning mo ni iyahang maximum current across it. Through it, I mean. 146. Okay? Hindi na kani siya na important. So, sige let's try to solve some examples. Okay. Yeah. Pinag-adaptor. Given. So for example, we have this circuit. So voltage source is 16 volts. RS is 1 kilo ohm. RL is 1.2 kilo ohms. So fixed sila tanan. And ito is Zener diode across our load, having these characteristics. VZ is 10 volts and PZ max is equal to 30 milliwatts. Okay. Some questions there. Solve for VL. IZ or current sa Zener Diode, and PZ. So it's important for us to know if ang power ba nga gi-dissipate no or gi-consume sa atong Zener Diode is wala pa ba na-reach niya ang maximum, which is 30 milliwatts. Kaya kung ma-reach po na, maguba po na itong diode. No? Even if na-conduct siya sa reverse bias region. First is, sige, try to solve. First, ako i-determine ang state ni Zener Diode. So, how do we do that? For a moment, try to imagine nga wala pa si Zener Diode. No? So, how much is the load, the load voltage or the voltage across the 1.2 kilo ohm? What do we use? We use what formula to solve for the voltage across here?
Voltage divider, sir.
Okay, thank you. Voltage divider. So, yes, V2 is equal to Vs R2 over R1 plus R2. 16, 1.2 over 1.2 plus 1. Pila? Pila ni? 2 plus 2.2. 8.73 volts. May problem. No? Remember, I think wrong ni siya nga notation ni gamit. When V voltage across the load, dapat ni. Dire, oh. VL dapat ni siya, oh. So when the voltage across the load is greater than or equal to VZ, the Zener is... Ay, wait. Of course, basta ko si VI. It's a VZ. Lagi sakto. Even ang load, no? Even dapat ang load mansad. Sakto to ganyan. So if the load voltage is greater than VZ, then the Zener is on. But if it's less than VZ, it's off. In this case, atong example, how much is VZ? Diba? 30 volts. No, 30. 10 volts. But the voltage across the load is only 8.73. So what would happen? No, naka-off ang atong Zener diode. So it's as if malalag normal nga wala siya dito. So our circuit is just like malalagid normal nga voltage divider. And we no longer to solve for IZ because it's open circuit. We know it's 0 amperes. And power dissipated by the diode is 0 watts. So we need a new value for RL siguro. No? So what if RL is 3K? This time, 3 kilo ohms. 3 kilo ohms. Same gapon. Let's solve for the the measure of the voltage by using voltage divider. 16, 3K over 3K plus 1K. 0.75 of 16, which is 12. 12 volts. Yeah. Because now, V2 is greater than VZ, which is only 10 volts, the diode is on. Now, what would happen to the circuit? Earlier, when our Zener diode was off, okay, wala siya, no? Open circuit. But this time, the Zener diode is on. So, actually, di mo na ito i-redraw itong circuit as is lang siya. Ako lang i-iterate dito sub. Na. But, the voltage drop across the resistor is not anymore 12 volts. Again, iyahang purpose is to regulate voltage. Is already 10 volts only. Okay? So how much would our R1, the value across R1 be? VR1. Would like to guess? Ay, makatag na. Pilay voltage across R1. Voltage source is 16. Voltage across R2 is regulated at 10 volts.
6 volts raw, sir.
6 volts. Okay, very good. So, i-ditch na itong minus, no? Because fixed naman ang voltage across the load at 10 volts. Ano yung purpose sa Zener Diode? So, napugong ang atong voltage at 10 volts. So, yes, VR1 is 6 volts. So, sa ani, could we solve for IR1 and IR2 then? IR1 is Ohm's law, V equals to IR, I equals V over R. So, VR1 over R1. Same goes for IR2, VR2 over R2. Ila ba? 6 volts over 1K. This one, 10 volts over 3K. 6 divided by 1K. 6 milliamperes. Okay, 6 milliamperes. 10 divided by 3K. 3.33 milliamperes. How much then is IZ class? Considering that this is a node, mo ni ang IR1. Panaog si IR2. And padulong dito si IZ. So by virtue of KCL, how much is IZ?
2.67 milliamps, sir.
Okay, thank you, Nico. So 6 milliamperes minus 3.33 milliamperes is equal to 2.67 milliamperes. Very good. Last, how much is the power dissipated by the diode? PZ is IZ VZ. 2.67 milliwatts times kilovolts na nalagay 10 volts. So 26.7 milliwatts. Layo pa siya sa maximum rating. Dili pa maguba ang atong Zener diode. PZ is 30 milliwatts. So, ang kaning atong 26.67 is still less than the rated power of 30 milliwatts. So, pwede lagyan po naman conclude that diode is okay. Okay? Any clarification so far sa solution? Blah, blah, blah. Is there any questions? If none pa so far, sige, let's try to solve another example. Notice earlier, sa example number 1, that at 1.2 kilo ohms na load, off si diode. Right? But, at 30 kilo ohms, 3 kilo ohms, on na si diode. No? So, this gives us an idea na naday value for any circuit nun ay specific value for A load kung kanus off si Zener diode and on si Zener diode. So, kana itong next na example. So, supposing same gapon ng circuit, no? $50, 1 kilo ohms, and the load is variable. So that's the symbol for a variable resistor. Resistor nga na ay diagonal nga arrow. And natin i-connect dili nga Zener diode. Having these ratings, characteristics, VZ is 10 volts and IZ is 32 milliamperes. So, maximum ni siya, meaning this is its rating. Pwede mo greater than 32 milliamperes ang IZ. Ang actual IZ. So, question here is, minimum value for RL to turn Zener diode on. And the maximum RL such that Zener diode does not burn, be destroyed, so not be busted. Okay, kung nakuha kayong RL, basta maabot ang okay? Oh, yeah, manublang value sa RL might be nakuha kayong current kung mag-flow sa Zener diode. Sige daw. To solve for the minimum value of RL, actually, you only need to use voltage divider. No? So when we say the minimum RL to turn the Zener diode on, the moment it turns on, automatic that the voltage drop across the diode and sa load will be equal to 10 volts. Automatic. So we'll use that for our calculation. To solve for V2. Using voltage divider. V2 is equal to Vs R2 over R1 plus R2. V2 is 10. Vs is 50. R2 is unknown. R1 is 1K plus an unknown R2. And I think makaya na shift solve calculator. R2 is equal to R2 is 250 ohms. So, more na siya ang answer sa minimum value of RL. Meaning, below 250, the voltage across the load will be below 10 volts. Thus, ma-open circuit ang atong Zener diode. Sure, pwede naman natin i-try, no? What if 200, no? Or 240? So, 50 over 240 over 240 plus 1K. 1K man si RS. Notice that V2 is equal to is only 9.67 volts, which is less than the 10 volts na need ni Zener diode. Okay, so next is how to solve for the maximum RL. Before we do that, we need to find or search for the resolve for the current across the load. and also across the source resistance. So, sugod ta dito. IR1 or RS dapat to, no? IRS. Current IR1, wala ko day. Kung sa una, VR1. How much is VR1 then? No? Without solving, source is 50 volts, voltage across load is 40 volts, no, 10 volts. So, mo itong VR1, 40. So, 50 minus 10. Fixed na siya at 10 volts because mo ng characteristics of a voltage divider. So, VR1 is 40 volts. IR1 could easily now be obtained. I equals to V over R, VR1 over R1, 40 over R1, 1K. So, 40 milliamperes na eh. Hindi po ako masayop. Yeah, so it's 40 milliamperes. Considering again, node A, going dito si IR1, going dito si IR2, or current sa load, and dito si IZ. So, by virtue of KCL, meaning IR1 is equal to IZ plus IR2. IR1 is 40 milliamperes is equal to IZ. Given mo si IZ? IZ max, 32 milliamperes. So this is a maximum value for IZ. 32 milliamperes plus IR2. Therefore, IR2 is equal to 32 minus 40 is equal to 8 milliamperes. So, 8 milliamperes ang maximum load current. Maximum load current as a class. Bali, 40 minus 32 ay dapat. Because 32 is V, maximum voltage. Supposed to be that's across the Zener diode. That would also mean that 8 milliamperes should be the maximum pod current na flow sa load resistor. So if you already obtained IR2, we could solve for the maximum value for R2. I over R. V over I. V R1 over I R1. V R1 is 2 day dapat ni 2. VR2 and IR2. VR2 is ito kanina 10 over 8 milliamperes. Ilan na siya? 10 divided by 8. 1, 2, 50 ohms. Any questions? Meaning if we graph this one, maging ani, no? So before 250 ohms, 0 ang current na mag-flow. So, wala. So, at 250, ay pa mag-on. And, tama na po siya sa 1 to 50 ohms. Anything above 1 to 50 ohms will make the diode, will destroy the diode. Any questions so far? Wala pa? So, okay. Last example. So, what if this time, ang ato na po source ang variable? $220 ohms, 1.2 kilowatts. Kilo ohms, I mean. VZ is equal to 20 volts with a current rating of 60 milliamperes. So, ang question lang here is solve for range of Vs such that Zener diode is on. Ayan lang, no? R2 is fixed, R1 is fixed, Vs is variable. So first goal na to is at what voltage Vs will the diode turn on? The same as before, we'll use voltage divider. V2. So V2, if indeed Zener diode is on, will be 20 volts. So V2 is equal to Vs R2 over R1 plus R2. So V2 is 10 volts. Vs is unknown. R1 is 1.2K over 1.2K plus 220 ohms. Yan si Vs. 10 divided by 1000 1,200 plus 1,200 over 1,200 plus 220. 11.83. $11.83. At this voltage source, diode will turn on. So anything below ani, let's say for example 11 volts. So if 11 volts times 1.2 over 1.2 plus 220, $9.97, no? So example lang. Example, Vs is only 11 volts. That would make V2, if itong isolve, 9.27, which is less than the 10 volts ni, ito? So ito gini. They need 10, 20, just 20 man yung given day. Yung,
Lagi sir, mapurang pangutana. Okay. VZ din na siya sir, din na siya V2.
asa kaning 20?
Walang V2 mangguling mo butang sa voltage
V2.
divider.
20 na siya. 10 tong ganina sa for example. 20 dapat niya din. 20. Sorry. So, 20 divided by 1,200 over 1,200 plus 220. 23.67 day dapat. 67. No? So, example 23 volts, no? Dili siya 11. Example, Vs is only 23 volts. So, V is equal to 23 times 1.2 over 1.2 plus 19.43. Which is less than this one, 23.67. No. 23, 22. Pila ba? Pila ba? 20, no? 20 volts. 20 volts na yung VZ. So, if ang atong voltage source is only 23 volts, dili enough ang 19.43 para abuton ang 20 volts across the Zener diode. No? So,
Ang
this is
solution,
just ang...
clarify na ko sir. Ang
Yeah.
solution na to yung 19.43 is KCL?
Dili, kuan
Oh.
lang, voltage divider.
Voltage divider yapon. Okay, so
Voltage
exactly the
divider.
same.
Nag-suppose lang ko nga 23 volts lang ang source.
Okay, makes sense sir. Sige. Thank you sir.
Okay. So again, kung 23 volts lang ang source, dili enough. Nga mabot ang 20 volts ni Zener diode. So dapat 23.67 siya. No? So range 1. At what point then, or at what source voltage will the Zener diode be busted? No? So if 23.67, kasi variable, say kondiling. Ang fixed dire is ang load, no? Load. So fixed pud ang current sa load, IRL. R2 na lang. R2 na lang gamitin. Ay, R2. Which is VR2 over R2. VR2 is fixed at 20. R2 is 1,200 ohms or 1.2 kilo ohms. Meaning IR2 is equal to 16.67 milliamperes. So, fixed na siya. So, dire na ay 16.67 milliamperes. Dire, maximum niya is just before siya maguba, 60 milliamperes. Meaning, the maximum current across R1 by virtue of current law is IZ plus IR2. IZ is 60 milliamperes plus 16.67 milliamperes. Therefore, IR2 is 76.67 milliamperes. Hindi mo yung maximum current sa source resistor or R1. Meaning, we could solve for the maximum value for voltage across R1. VR1 equals to IR, ay, 1 dapat ni. IR1, R1. $76.67 times, ilang R1? 220. Meaning VR1 is equal to 16.87. So if we add this one with IR2, VR2, that would be our maximum value for our voltage source. 16.87 plus 20. 36.87 volts. Maximum value for Vs. Any value above 36.87 volts, let's say for example 37 volts, meaning dako ang current na mag-flow sa Rs and mas dako ang current na mag-flow sa Iz. Okay, fixed man ang current mag-flow sa IR2. So if mo dako ni, then fixed ni siya. The only thing na magdako pa is Iz. So, di na pwede. Because 60 naman ang maximum dapat sa Iz. Anything above Iz, magbutol na siya. Okay? Questions? Sige, wait lang sa... sige, picture. Muna yung sa 2. Ang 3, okay na? Muna itong sa 1 kaganina. Sige, for the remaining time, try to solve this one daw. Number 42. This is just like example number 1 earlier. No? Para lang at least makapractice without that. Pila na din siya niya. Ano din D. So, okay na naman C ug D. Another way to term question C ug D kay what are the range of values, no, to keep the diode on state, no? Pero di. Sige daw. Try to answer this, guys. Dali naman niya siya. Then make sure na nag-solve mo karon kay you're going to take a photo of your solution and submit it sa e-learn as AC work nato this afternoon. Mm.
Pwede ra gyapon paint, sir ba?
Pwede la, pwede la. Mhm.
Excuse me, Sir Dale. No question regarding C and D.
Hello? Hello? May question sa pag-solve ani? Or straightforward la, same sa atong example ganina? Okay, if wala na, pwede na ta mag-dismiss. Kato lang ha, ang iyong solution, try to have a photo of it, then i-upload lang sa e-learn. Gibot naman po na ako nga unya pa ang deadline ato para at least na may time.
What time ni tawan, sir?
Gibutan ako 7 man siguro to. 7
Sige, sir.
plus.
Thank you kayo, sir.
Okay. Bitaw, napay question from the others? Okay, if wala na, sige, dismiss na to.
Thank you, sir.
Sige.
Bye, sir.
Thank you,
Yes, sir.
sir.
Thank you, sir.
Sir, may hapon
Okay.
guys. Thank you.
Thank you,
Sige,
sir.
maayong hapon. Bye-bye.